This lesson is a review of all the different kinds of factoring. So in each of these, we're looking to decide which of the ones from the last 4 lessons we want to use. So if we want the shortcut, if we're doing the long method, if there's a greatest common factor, whatever. So we're going to look at each of these and decide if there's a greatest common factor. So in number 1, are they all divisible by anything? No. So its greatest common factor is 1. So then I want to look at this. There's 3 parts to it, and I say, okay, my a value is just 1. So if your a value is 1, that means we want to make an x, and this is the short way. Okay, so this is the short method. So our a times c is 24, and b is 10. So what multiplies to give you 24 that adds to 10 is 6 and 4. So this one, you don't have to do the long method of finding the greatest common factors of these. Because your a value is 1, it's just x plus 6 and x plus 4. So if you wanted factored form of that, that's factored form. If you wanted your exact answer, you would set these equal to 0 and get -6 and -4. Okay, so looking at our second one, is there anything that divides all of these? Well, the first thing I see is they all have an n, so I can take an n out, and I know that they're all divisible by 3, so I can take 3n out in front. So when I take 3n out in front, I'm left with n squared minus 12n plus 27. Then I have to look and see, am I done yet, or do I have more to do? Well, there's definitely more to do in this, because our a value is 1, and there's 3 parts to this, so we have to see if we can factor it. So what multiplies to 27 and adds to -12? So what does that is -9 and -3. So again, because our a value is 1, we did greatest common factor, and then we can go short method. So the 3n stays as our answer, and n minus 9 and n minus 3 are our solutions. So if you were going to find exact solutions for this, you would set each of these equal to 0 and solve them. Well, when you divide this, you're still going to get 0. When you add this, you'll get 9. And when you add 3, you'll get 3. So you have 3 different solutions to this one. Okay, next one. Is there a greatest common factor in this? Well, yeah, they all have an x that you can take out. So I have x squared minus 11x plus 10. So now when I look at this, I say, okay, can I do anything with stuff inside the parentheses? My a value is 1, so I'm going greatest common factor, and then I'm going short method. So what multiplies to 10 that adds to -11, what's going to do that is -10 and -1. So this x stays out in front. I have x minus 10 and x minus 1. And again, if you want exact solutions, you're setting them each equal to 0. So I would get 0, 10, and +1 as my exact solutions to this. But if it's just asking you to factor, then you would stay with your green answer. So what's in common between these two? 5 and x. So if you take a 5x out in front of that, you're left with x minus 3. So that would be your factored solution because there's nothing squared, so you can't set up anything. If you wanted to, you can set these equal to 0 and solve for them. So when I set that equal to 0, I get 0. When I set that equal to 0, I would get 3. My greatest common factor here is k squared. So I would take k squared out in front, and I'd be left with 5k squared plus 4k and minus 9. So I need to look inside the parentheses. So my a value on this is not 1. So this one is greatest common factor, and then the long method. So the long method for this, it has to multiply to a times c, so -45, and add to 4. So what does that is 9 and -5. So when you do 9 and -5, remember that the k squared is going to keep sitting out in front. We're going to have 5k squared and -9 that stay. And in place of 4k, we're going to go plus 9k minus 5k. Okay, so then I'm looking for greatest common factors here. What divides both of those is k, so I'm left with 5k plus 9. What divides both of these? -1. So I would have 5k minus 9. So my solution to this problem would be k squared, then k minus 1, and then 5k plus 9. And if you wanted the exact solution, setting these equal to 0, you'd get 0. Setting this equal, you'd add the 1 to the other side. And this one, you would subtract 9 and then divide by 5. So the green would be your factored and the black would be your exact solutions of those. Looking at number 6, what's in common? Well, I know that I can divide both of those by 2 and I can take out an x. So 2x comes out in front. I have 7x plus 6. So that would be your factored solution. If you want your exact solution, setting this equal to 0 would be 0. This one I would subtract 6 and then divide by 7. Our last one's on here. This one does not have any greatest common factor, so if it doesn't have a greatest common factor, it's going to be 1. So then I look at my a value. So this is going to be the long method. So I'm multiplying a times c, which is 30. It has to add to negative 17. So what's going to do that is negative 15 and negative 2. And remember with long method, 10x squared and 3. In its place, negative 15x minus 2x. Okay, so I want to group these, my first two and my second two. So what divides 10x squared and 15x is 5x, and I'd be left with 2x minus 3. And then on this one, in order to get this to become 2x minus 3 inside, I would have to divide everything by a negative 1. So my factored solution is 5x minus 1 and 2x minus 3. If you wanted exact solutions, you would move this around. So I'd add 1 and then divide by 5. Here I would add 3 and divide by 2, and those would be my two exact solutions. Okay, looking at this last one, there's nothing in common between these, so its greatest common factor would be 1. When I look here, that tells me that I want to do the long method. So I have to multiply a and c, which is negative 40. So it has to add to negative 3. What's going to do that is negative 8 and positive 5. So I have 8p squared and the negative 5. In between, I have negative 8p and 5p. Group these. So I have 8p that divides both of those. That would give me p minus 1. And then grouping these, 5 would divide both of those, and I'd have p minus 1. So I have 8p plus 5 and p minus 1. And if you want your exact solutions for these, set them equal to 0. This one's the easy one because you would just add 1 to the other side to get 1. This one you'd subtract 5 and then divide by 8 to get your two solutions. And that's a pretty decent review of just general factoring.